What's the buzz about the decorator pattern? Picture this. You're an artist and your canvas is an ordinary object. But wait, you want to sprinkle it with magic. Add a dash of color, a pinch of functionality, and a touch of awesomeness. That's where the decorator pattern comes in, like a creative superhero. So where is it used, this decorator pattern? Java I/O streams could be an example. Think of I/O streams like data pipelines. Want buffering? Decorate your stream. Need encryption? Add another layer. Collections are another example. A simple list gets sorting functionality added. And that same list could get filtering and transforming functionality if needed. Hi, my name is Gene and welcome to this channel. Let me tell you what we'll be talking about in this video. First, we'll dive into the basics of the decorator pattern. Then we'll apply our knowledge by creating an example in Java. After that, we'll do the same thing by creating an example in Python. And after that, we'll be talking about a couple of caveats to take care of when making use of the decorator pattern. But more on that later. So let's talk about the structure of the decorator pattern. The first thing that we need is an abstract component. This is an abstract representation of the functionality that we want our classes to implement. In our example, this would be the method operation, returning void. But obviously this is the place where you could add any method that you need. The second class that we need is the concrete component. This is the class that actually implements the functionality of the abstract component, meaning in our example, a public method called operation, returning void. The third class that we need is the abstract decorator. Like our class concrete component, the class abstract decorator also implements the class abstract component, which also means to implement a public method called operation, returning void. What the abstract decorator also does is define a private variable called component, having the type abstract component. And this is why we speak about an aggregation between abstract component and abstract decorator. What we need now is a fourth class that we call concrete decorator, which will extend the abstract decorator. This is the place where the actual decoration takes place, meaning that we could have multiple decorators here, depending on our needs within the application. Okay, so let's create ourselves a Java example. The first thing that we need is the abstract component. So we create ourselves a file called abstract component.java, which is an interface where we define a method operation that returns void operation. That's it for the abstract component. What we want to do now is implement the abstract component in a concrete component. For that, we will create a file called concrete-component.java, in which we will implement the abstract component, which will force us to override the method operation. So public returns void operation. And here we do something. For the purpose of this example, we will output a text to the command line. System out print line operation of the concrete component. That's it for the concrete component. The next thing we need is the abstract decorator. For that, we will create a file called abstract decorator.java, which is abstract and which implements the abstract component. This forces us to implement the operation method, override public void operation. And now we need to do something. For that, we need a protected variable of type abstract component that we call component. Now, the reason why we use protected and not private is because we may want to access the variable component from classes that extend the abstract decorator. So now we also need to fill the variable component. And for that, we need a constructor that takes the component as a parameter. Public abstract decorator takes an argument of abstract component called component to set this component with the parameter component. Now we can access the component to reach its operation. This component operation. That's it for the abstract decorator. What we will need now is a concrete decorator. And as we will have more than one, we'll create ourselves a concrete decorator A and a concrete decorator B. So let's start with a concrete decorator A. Concrete decorator A.java. This class extends the abstract decorator. The first thing that we need is a constructor so that we can take the abstract component as a parameter and save it locally in the abstract class that we just extended. So public concrete decorator A takes an abstract component called component, which we store in our super class, which is the abstract decorator, super component. And as the class name already suggests, this class is a concrete representation of a decorator. This means that we can add behavior. So let's first define what type of behavior we want to add. We create ourselves a method for that. Private, doesn't return anything, so void added behavior. Doesn't take any parameter, but outputs a text. System out print line added behavior from concrete decorator A. This is the behavior that we want to add. Now let's override the operation method. Add override public void operation, no parameter. First we want to output whatever is defined in the operation, super.operation, and then we add our own behavior. This added behavior. Now let's create another concrete decorator. Concrete decorator b.java extends abstract decorator. Again, the first thing is to create ourselves a constructor. Concrete component b takes the abstract component as a parameter and stores it in its superclass. Then we define added behavior. Private void added behavior. System out print line added behavior from concrete decorator B. And like before, we need to override the operation method. Public void operation, no parameter. First we execute the operation itself, then we add our behavior. And that's the basic structure of the decorator pattern. What we need now are a couple of test cases that we will define in the main method. So let's create main.java, where we have our main method, public static void main. Taking a string array parameter, which we will not need though. Let's create ourselves the concrete component, which we store in a variable of the type abstract component. Abstract component, component, new concrete component. We could already output this component. So let's do that. System out print line, concrete component, and now the operation of the component. Let's create an empty new line. System out print line. Now we can create ourselves a new component that we decorate with the decorator A. Abstract component that we call decorated component A. And now we make use of the concrete decorator A, where we pass on the component which will be decorated. Again, we create ourselves an output. System out print line decorated component A and decorated component A operation. Let's create an empty line for that again. And let's do the same thing with the concrete decorator B. Abstract component decorated component B, new concrete decorator B takes the component. Now we output system out print line decorated component B, and let's execute it. Decorated component B operation. What we also can do is nest the different decorators. So let's create one example for that. Again, a new line, abstract component, decorated components A and B, new concrete decorator A, which takes the component as a parameter. And now we wrap this one in the concrete decorator B. New concrete decorator B takes the parameter of the result of decorator A. Now we create ourselves an output. System out print line decorated component AB. Decorated component AB and operation. That should be enough test cases. What we need now is to tell Java what classes to execute. For that we need a manifest.text. Main class is main and enter. What we need now are two scripts to create the application, one for Windows and one for Mac and Linux. So let's start with the Windows file. Build.cmd, add echo off. Now create a class file of every Java file that you find, and then pack everything into a jar file named decorator demo.jar, where you pack the manifest.txt in it and any class file that you find. Let's repeat the process for the shell file for Mac and Linux. Build. This time we address it to bin bash and we remove the echo off. The rest remains the same. We now need two further files to run the application. One for Windows, run.cmd, add echo off, java jar decorator demo.jar. That's all we need. Let's repeat the process for the shell. Run. We address it to bin bash and remove the echo off. The rest remains the same. What we now need is to provide execution rights for the shell files. This step is not necessary for the Windows files. Let's first check what files we have. We want to provide execution rights to the run and to the build file. chmod, give execution rights to build and run. Let's check. And there we go. We have execution rights for the build and for the run. Now we are ready to build and run the application. So let's build the application and run the application. Let's put the main.java into context. The first thing that we do is to create the normal component, create an output text and run the operation, which is what we did here. Then we have a new empty line, which is this one. The next thing that we do is to decorate and output the component using the decorator A, which is what we do here. Then we repeat the process using the decorator B, which is here. And then we have our nested example where we use both decorators, A and B, which is here. Let's create ourselves an example for the decorator pattern in Python. The first thing that we need is the abstract component. So let's create a file, abstract component.py, creating a class called abstract component and defining a method called operation, taking self as the parameter but doing nothing. That's it for the abstract component. Now let's create a concrete component. For that we create ourselves a concrete component file where we import the abstract component from abstract component, import abstract component. Our class is called concrete component, implementing abstract component. And here we implement the method operation, taking self as a parameter. And here we output a simple text to the command line, operation of the concrete component. That's it for the concrete component class. The next thing will be to create ourselves an abstract decorator. For this we need a new file called abstract decorator.py, importing the abstract component from abstract component, import abstract component. And our class is called abstract decorator. implementing abstract component. To remember the component, we define ourselves an init method, def underscore underscore init underscore underscore, take self as a parameter as well as the component, and we store the component in self underscore component equals component. What we need as well is the operation method, taking self as a parameter, executing the provided operation. So self underscore component dot operation. That's it for the abstract decorator. What we now want are the same two concrete decorators that we defined in the Java example. The first file is for concrete decorator A, concrete decorator A.py. Here we need to import the abstract decorator. From abstract decorator, import abstract decorator. Our class is called the concrete decorator A. Concrete decorator A. And it implements the abstract decorator. So the first thing we want to do is to create the added behavior. Define added behavior, taking self as a parameter, and printing added behavior from concrete decorator A. And the next thing is to implement the operation, def operation, taking self as a parameter, executing the operation of the superclass, super and operation, and adding our own behavior, self.added behavior. That's it for the concrete decorator A. And now we create ourselves another decorator called concrete decorator B. For that we need a file, concrete decorator B.py, importing from the abstract decorator. Our class is called concrete decorator B, implementing abstract decorator. Here again we define our added behavior, taking self as a parameter, and we print added behavior from concrete decorator B. We also need to implement the operation, def operation, self. Here we also call the superclass with the operation, and we add our added behavior. That's it with building up the decorator pattern in Python. What we now need is to create the test cases within the main method. So let's create ourselves a main.py and import the classes that we need. The first one that we need is the concrete component. From concrete component, import concrete component, and then we need the two decorators. From concrete decorator A, import concrete decorator A. From concrete decorator B, import concrete decorator B. Here we can now define our main method, starting with the concrete component. Component equals concrete component. What we now want is to print the operation. So first let's announce it. Print concrete component and component operation. Now let's create an empty line and decorate the concrete component with a concrete decorator A. Decorated component A equals concrete decorator A, and we provide as a parameter the concrete component. Let's announce it. Print decorated component A. Decorated component A.operation. Okay, let's repeat the process for the decorated component B. Decorated component B, concrete decorator B, component, print decorated component B, decorated component B, operation. Okay, that's it. Now let's create the last test case with the nested decorators. Print for a new line, decorated component AB, concrete decorator A component, and now put that in the concrete decorator B. Announce it, decorated component A, B, and execute the operation. That's it with the test cases. Now we need to tell Python to execute the main. If underscore underscore name underscore underscore equals underscore underscore main underscore underscore. If that is the case, execute main. And that's it. The only thing that remains are two scripts that we need to create, one for Windows and one for Mac and Linux, so that we can run the application. So let's start with the Windows file, run.cmd, add echo of python main.py. That's it for the Windows script. Let's create a shell script for Mac and Linux. Run. Here we need to address it to bin and bash, and then tell Python 3 to run main.py. The only thing that remains are the execution rights that we need for the shell script for Mac and Linux. Let's check what files we have. We need execution rights for this run file. Change mod, give execution rights to run. Check. And there we go. Now we have execution rights for the run. Now let's run the application. And there we go. Let's compare it to what we defined in the main. In the first segment, we create ourselves a concrete component and execute the operation. And this is exactly what we do here. In the second part, we decorate the concrete component with the concrete decorator A, which is what we do here. Then we repeat the same thing with concrete decorator B, which is what we do here. And then we have our nested example, which is here, and the result is here. As I'm very interested in how others make use of nice technologies such as the decorator pattern, I'm also interested in what you do with it. Have you ever used the decorator pattern in your projects? If you have, drop a comment below and tell me where you used it. I'm curious to see how you put it in action. Also, if you prefer reading the content at your own pace, I've got you covered. All the information you're seeing in this video is also available on my website. Now, all the codes I worked with in this video are also available on GitHub. You can find the links in the video description below. I must say though, I'm glad you're here watching this video. It's always fun to interact and explain things visually. So let's talk about the caveats regarding the decorator pattern. The first point concerns complexity. As you add more decorators, the number of classes and interfaces may increase significantly, leading to potential complexity and maintenance challenges. Be cautious not to overuse the pattern, especially for simple cases where simple solutions might suffice. The second point is about duplication of functionality. There's a risk of duplication of functionality across decorators, especially when decorators aren't designed carefully. Avoid redundancy and ensure that each decorator adds unique behavior or functionality to the component. The third point is about a possible performance overhead. The decorator pattern introduces additional layers of abstraction, which can potentially impact performance. While the impact may be negligible in many cases, it's essential to consider performance implications, especially in performance-sensitive systems. Topic number 4 touches the topic of serialization. So, serializing and deserializing objects can be quite complex. If your application involves serialization, you may need to implement custom serialization logic to handle decorators properly. Alright, that's it for the decorator pattern. There will be more topics like this on this channel. Let's find out together what the next video will be about.